So far in our discussion of relational algebra, we've talked about how to find and how to combine information in and from different relations. Clearly, when we're working with data in the real world, we need to change the data that's stored. We need to add data, sometimes delete data, change data, and so forth. And how do we do this within the framework of relational algebra? What are the mathematical operations for adding, removing, and so forth, modifying data within relations? Well, a relation itself is a mathematical object, and it itself doesn't change. But what we refer to by a particular name or a particular variable, that can change. So if we want to talk about the basic ways of modifying information in relations, the idea is we reassign the relation that we're talking about to some transformed version, to a transformation of the original relation. So if we reassign the variable r to be this new relation, the relation that is the union of the old r together with e, we've essentially added those tuples into the relation, at least into the relation that we're now talking about. In the same way, we can use set difference to delete tuples. If we reassign r to be r minus this set of tuples e, we've essentially removed the tuples in e from r. And if we want to update tuples, we can, as we will see in a little while, use generalized projection to change the information in particular tuples within R. We reassign it, and now we have a new set of tuples with the new information. One important thing to remember when we're using relational algebra to represent changing relations is make sure that you don't forget to include all of the tuples that have not changed. So if you're changing some information, make sure that the unchanged tuples are retained in the new relation, because otherwise you might lose them without even noticing. And we'll see that in a few minutes. So to expand a little bit, if we want to add new tuples, we say R will be reassigned to R union E, where E contains those new tuples that we want to add, with one very important condition. The tuples in E must have the same schema as R. That means they have to have the same arity, which means the same number of attributes, and those attributes have to have the same domains. If E's schema does not match R's schema, this will result in something which is not a relation, because a relation is a set of tuples that all have the same schema. That's the definition. So we need to make sure that E's schema matches R's schema. If we assume that, there are a couple of different ways of specifying adding new tuples, adding new information into a relation. We might specify certain particular constants. So for example, if we have a relation that's representing some set of books, where each book is represented by its ISBN number, its title, and its author, we might add two new books, To Kill a Mockingbird by Harper Lee and 1984 by George Orwell, by saying books is reassigned to be books union the set of the tuple representing To Kill a Mockingbird and the tuple representing the book 1984. Another way to specify adding new tuples is we might give some expression which evaluates to a tuple or a set of tuples that we want to add to the relation. So if we have a relation representing information about all of the employees in the company, we might want to add a new employee, May Wen, whose salary is going to be 20% higher than existing employee Oliver Smith. Slightly artificial example, but suppose we wanted to do that. We could say, well, the employee relation is reassigned to be the employee relation union a set with a new tuple, May Wen, with a salary of 1.2 times the projection down to salary of selecting the employee with the name Oliver Smith. Now, this particular expression is a little bit artificial, and you may see immediately that there are some difficulties with it. Maybe there's more than one employee with the name Oliver Smith. We didn't assign May Wen a new ID. We would have to deal with all of these details in a more realistic example, but this is just to give you the idea. What do we do if we want to remove information? As we said before, the basic idea is straightforward. R is reassigned to R minus some set of tuples that we want to remove. Now, if the set of tuples in E does not have the same schema as R, this is a perfectly safe thing to do because then we just won't remove anything because those tuples will not match anything in R. So we've just removed nothing. But if we actually want to remove something, we need to make sure, again, that the schemas are the same. So we may specify it by deleting a specific tuple. We might say, well, we want to remove To Kill a Mockingbird from the set of books in our relation. So books is reassigned to books minus the set containing that tuple representing the book To Kill a Mockingbird. We may also delete tuples that match certain conditions. To find the tuples that match the desired condition, we use the select operation. So we might say the employee table is reassigned to employee minus select those employees with a salary greater than $150,000. Selecting those employees will give me a set of tuples representing those employees. The set difference here will remove them from the relation and give me the relation of all the tuples except for those. Reassigning to the employee table effectively deletes them from the relation. Deletion is an operation which is a little bit fraught. Let's see what can happen. If two different relations are linked via a foreign key. So for example, suppose we have a library application where we have a list of everyone with a library card. So they have a borrower ID and their name. And then we have another table listing each book and who is currently borrowing that book. So the borrower ID in the books table refers back to the borrower's ID in the borrowers table. So suppose Alice leaves the library and gives up her library card. So the simple way to delete Alice's data is we just select the borrower whose name is Alice from borrowers. That gives us her tuple in the borrowers table. And we just remove it from the borrowers table. So here's the result that we're going to get. Now there are only two borrowers, Bob and Charlie. Look, can you see the problem? Here's the problem. We've removed Alice. However, Alice is still referred to as the borrower of two of the books. We have a foreign key in the books table that is referring to a record that no longer exists. So we need to make sure to fix those links so that we're not referring to non-existent data when we've deleted data from one table. So the first thing we need to do this properly is, first, identify the data to be removed. So we'll set this intermediate variable, Alice tup, to refer to the tuple of Alice within the borrowers table. So we'll find Alice within the borrowers table. Then we need to know Alice's ID to identify everywhere that ID is used as a foreign key. Because in every place that Alice's ID is used as a foreign key, we will need to change that value to null because that value no longer points anywhere once we've deleted Alice from the borrowers table. So the next step is to find where Alice occurs and reset that value. So we now go down to the books table, and first, remember what we said before about making sure we keep all unchanged data? The first thing is find all of the tuples that do not involve Alice's ID as a foreign key and just keep that information. So the books table is now going to be the union of the books that Alice did not borrow. So we select borrower's ID not equal to Alice's ID from books and then union it with the result of changing the data in the books that Alice did borrow, the ones highlighted here in orange. Everywhere Alice's ID is the foreign key, we project to change that ID to be null. So we set the borrower's ID to be null because these books are no longer borrowed by anyone once Alice has left the library. So the books table has now been changed appropriately so that the foreign key of Alice's ID no longer appears anywhere. Now it's safe to remove Alice from the borrower's table because she's not referred to anywhere else in our set of relations. So now we can update borrowers to borrowers minus select name equals Alice from borrowers, and all is well. In this extended example, we talked about updating the tuples with Alice's ID as a foreign key to be null. Let's look at this operation in a little bit more generality. Updating a tuple can be done by using generalized projection. We update the relation to be generalized projection of the original relation to change some of the data in some of the tuples. Here are a couple of examples of how this might work. Suppose we want to give everyone in the company a 10% raise. That would be nice, right? So we can use generalized projection. We project all of the attributes in the employee table to themselves. We keep all of them. We keep employee ID, name, everything else. But when we project salary, we project it to be 1.1 times the salary. So now we have a set of tuples with all of the information the same, except that the salary is increased by 10%. That information is then stored back in the employee variable, which updates essentially all of the tuples to have a 10% higher salary. Suppose we want to do something a little bit more sophisticated. Suppose only the finance department employees get the raise this time around. So we want to give everyone in the finance department a 10% raise. This is similar to the case earlier when we were updating only those tuples which had Alice's ID to change the borrower's ID to null. So here we need to make sure everyone not in the finance department is kept the way that they are, and then everyone in the finance department gets the 10% raise. So here we need to do a join between the employee table and the department table because we don't know the names of the department and the employee table, just their IDs. So first we select all of the employees with the department name equal to finance from employee join department. That gives us then all of the employees' information plus the department name, but only when the department is equal to finance. Those people are projected through to give the employee ID, the name, and so forth according to the employee schema with the 10% raise on the salary as noted. But we also need to make sure to select everybody whose department name is not finance and to project their information into the employee relation without changing anything. So we need to always make sure we know what we're changing, we change it appropriately, and we know what we're not changing, and we don't change it appropriately. And here we see the beginnings of how we're building more complex operations out of the simpler operations here: select, generalized projection, and join. And as we move on and learn more about how to use relational algebra for different applications and how to implement relational algebra in actual systems through the language SQL, we'll see how to do this in more sophisticated ways, and you will be able to build very interesting applications yourself.